All right, so last week or last video we talked about solving absolute value equations when they were already isolated. So now we're going to solve them when there's something outside. So the first thing we want to look at is getting the absolute value by itself. Okay. So I'm going to subtract the 7 since it's adding on both sides. Okay, which leaves me with just the absolute value of 6x plus 4 is equal to 11. Now I can set up my two equations. Remember, we set one positive and one negative. Okay, so now I can solve the two equations. I'm going to subtract 4 on both sides. 6x is equal to 11 minus 4 is 7. Okay, 6 is multiplying to x, so we're going to divide. So x is equal to, can't simplify that, so it's going to be 7 divided by 6. I'm going to follow the same steps on the second equation. I get 6x is equal to negative 15. Divide both sides by 6. And I get x is equal to negative 15 divided by 6. Doesn't simplify, so we're going to leave that as well. All right, so let's look at something multiplying outside the absolute value. Okay, so the 2 is multiplying the absolute value. Now with absolute value, I cannot distribute, okay? It is one of the grouping symbols I cannot distribute inside of. So instead of distributing, I'm going to divide, which leaves me with the absolute value of 6x plus 4 is equal to 18 divided by 2 is 9. Okay, I can set up my two equations, so I get 6x plus 4 is equal to 9, and 6x plus 4 is equal to a negative 9. Okay, and remember I can only set up the two equations once I've isolated the absolute value. All right, I can subtract 4 on both sides here, and I get 6x is equal to 9 minus 4 is 5. Divide both sides by 6, and x is equal to, okay, that doesn't simplify, so we're going to leave it as 5, 6. Solve the steps over here. Subtract 4, 6x is equal to negative 9 minus 4. Is negative 13. Divide both sides by 6. Again, does not simplify, so x is equal to a negative 13 over 6. All right, so looking at this one here, okay, what is my 6 doing? My 6 is dividing. So its inverse is to multiply. So I'm going to multiply both sides by 6. Cancels out on the left, and I'm left with the absolute value of a negative 3x minus 2 is equal to 30. Okay, I have my absolute value isolated, so now I can set up my 2. So we get negative 3x minus 2 is equal to 30, and negative 3x minus 2 is equal to a negative 30. Okay, solve my two-step equation now. Add 2. So we get negative 3x is equal to 32. Divide by a negative 3. And we get x is equal to negative 32 over 3. Okay, do the same steps on this side over here. Divide both sides by a negative 3. Okay, that doesn't simplify, but a negative divided by a negative is a positive. Yes, I know these are all fractions. All right. So, just like solving an equation, I always undo addition subtraction first. Now notice I've got something multiplying and adding this time. So I'm going to subtract the 21 first. So that still leaves me with a negative 3 times the absolute value of a negative 7x minus 4 equal to, okay, 18 divided by, or not divided, minus, sorry guys, 21 is negative 3. I still don't have the absolute value isolated yet, do I? So I need to divide both sides by a negative 3 since the negative 3 is multiplying. And we end up with negative 7x minus 4 in the absolute value is equal to negative 3 divided by negative 3 is a 1. So now that my absolute value is isolated, we're going to set up my two equations. So negative 7x minus 4 is equal to 1, and negative 7x minus 4 is equal to a negative 1. Okay, I'm going to add 4 on both sides. So negative 7x is going to equal 5. Divide by negative 7. X equals, can't simplify, 5 over 7. Okay, so I'm going to add 4 to both sides. So negative 7x is equal to negative 1 plus 4 is 3. We now divide by our negative 7. And we get x is equal to negative 3 over 7. All right. I know a lot of fractions today. That's okay. All right, so let's look at this problem here. My absolute value is isolated. Okay, but it's equal to a negative. So far we've had an equal to a negative. And we're going to talk about why we can't have equal to a negative in this. All right, so just for sake of working this out, I'm going to act like I'm treating this like a normal problem. So I'm going to set up my 2. Okay. So because the 4 is dividing, I'm going to times by 4 on both sides. So I get x is equal to negative 40 and x is equal to 40. All right, but I'm going to go back and actually check my work on this one and see if it works.
Water.
Thank you. So I'm going to take the absolute value of a negative 40 divided by 4. And I'm going to set that and that's equal to, we're going to see if that's equal to a negative 10. Well, negative 40 divided by 4 is a negative 10, isn't it? But what is the absolute value of a number? It's the distance from 0 on a number line. And remember, distance can never be negative. So if I have the absolute value of a negative 10, well, its absolute value is a positive 10. And a positive 10 is not equal to a negative 10. Okay, so that one didn't work. Let's go ahead and try the other one. We'll say the absolute value of 40 divided by 4, and let's see if that equals a negative 10. So we get the absolute value of 10. And the absolute value of 10 again is 10. And that is not equal to a negative 10. So, is there any way that an absolute value by itself would equal a negative number? And the answer is no. Short of putting a negative 1 out here on the outside, I cannot make this equal a negative 10. So in this case, if I have my absolute value isolated and it's equal to a negative 10, or equal to a negative number, we have a no solution. Because there is no number that I can plug in for x that will give me a negative number out.